we have spent some time. First of all, it was a nice back to the past. So we reviewed transformations. And the only difference, the added bonus, thank you, was that we added more vocabulary. So, folks, the vertical stretch determines what? The vertical stretch determines what? Good. The vertical shift or the vertical translation determines what? Good. The horizontal compression and stretch determines what? No. Period. And the horizontal translation determines what? Phase shift. Good. If a phase shift is to the left, what sign will the angle have? No, it'll be negative. So if it's to the left, it'll be negative. It will say x plus 90, but d is negative. Okay. Then we reviewed. And we had this formula, right? Because k messes us up all the time. To find out the stretch factor, you have to take the reciprocal of k, right? 1 over k. And because the period of a parent sine or cosine function is 360, we're going to divide it by the k value. Okay. Then we looked at some curves, and we talked about how the sine and cosine curve are really a phase shift of 90 degrees from one another. Then we talked about are you guys okay? Do you have questions? Oh, you know what? He already copied them down. It's okay. I'm kidding. Why don't you just print them? The PDF is there, so you can just print them if you want, But you're still going to want the notes, right? So I would print them. So then we talked about range, which is kind of, it makes sense, right? We talked about how you can go negative a plus c, positive a plus c. But then we talked about the domain, and the domain is going to be a tricky word situation, because in this case, it said the domain of the first cycle. Well, what if I said the domain of the second and third cycle, right? Doesn't that sound like a good thinking inquiry question? Yeah, it does, right? So there is a bit of mapping to find the new domain. Then we reviewed how to find the mapping notation, and we used the 5 key points of each parent function to transform the function and draw it. And then sometimes in the question, we are told what are the restrictions between which angles must we draw the function. So sometimes we have to work backwards or work forwards to fill in that full area that we are to draw in. And then we had a question like that, where we're given some characteristics and we had to draw the function. All right, so we arrive at the last question of this lesson, and that is how to determine the equation given a curve, given a graph. Okay? Now, if you look at this graph, folks, tell me, is it a sine curve or a cosine curve? I'm hearing sine, I'm hearing cosine, and then Miles was like, I don't know. Lila, what do you think? You're shaking your head. You don't know. Sebastian, what do you think? Cosine? Greg, what do you think? Sine, and it's flipped. Yeah, interesting. Other thoughts? Victoria, what do you think? Mesu, what do you think? Oh, come on. If there was $1 million on the line, if you get it right, come on. Okay, folks, why is Miles saying, I don't know? Yeah. Can it be a cosine curve? Yeah. Can it be a sine curve? Yes. It's a bit of a choose your own adventure, right? It just depends on the phase shift. So we know for parent functions, the phase shift between sine and cosine is just 90 degrees. It's a quarter of a cycle, right? 90 degrees is a quarter of a cycle. So when we write the equation, this could be either sine or cosine. And in a question, I might give you a curve and say, give it to me as a cosine curve. Give it to me as a sine curve, right? So you have to really look at the restrictions that I set. Now, luckily, we have some steps. The first step, as we look at this function, is to determine the amplitude. And we even have an equation for the amplitude. That is that amplitude is 1/2 of f max minus f min. Oh, yeah. So go ahead and find the amplitude. One half over x f max 8. Okay, that's going to be 12. Min is going to be minus 3. Oh, 8, 9, 10, 11. Oh, it's not 12, it's 11. Okay, 1/2 times 14 equals 7. Okay, that's what I got. Anyone else get 7? Yeah. Okay, what's up? No, great question. Amplitude is just a unit of measure. Can your height ever be negative? No, even if you're upside down, your height is still an absolute value. Okay, so it's just a unit, it's a way of measuring. All right, so we've got A. Let's make our list. We know A is 7. Now, so the amplitude is never negative, but can A be negative? If we had a negative A, what would it be implying? A reflection. Good. Yeah. All right. Step 2, determine the vertical shift. So how do I do that? What do I need to find? Okay, folks, which characteristic of the sine wave is represented by the vertical shift? The central axis. Remember, it used to be for the reciprocal, it was the asymptote. Now it's the central axis. So we're looking for the central axis. How far away from the maximum or minimum point is the central axis? 7 away. So do you know what I'm going to do? I'm going to either do some counting or do some math. 11 minus 7, well, that's just 4. Pardon? How did I do that? So I'm like, so I know that the amplitude is 7, okay? And if the maximum point is at 14, the amplitude has to be, like, it means that the maximum is 7 away from the central axis. The maximum is also 7 away from the lowest point. I need some darker color. Does that make sense? Okay, so I'm 7, right? I'm showing how it's 7 away. Okay, so I have my central axis, which is y equals 4. And in my list, I'm saying, okay, I know C. Now C equals positive 4. So there's a vertical shift up. Great. So we've got 2 parts of our equation. 3 more to go. Next, we're going to determine the length of one cycle, which will allow us to find K. So the length of one cycle is called the period. So let's first find the period. I'm going to go peak to peak, right? You can go trough to trough. So how long? So if this is at 360, and then this is at, I don't know. Okay, what does it go up by? 1, 2, 3, 4, 5, 6. So it looks like every box goes up by 30 degrees. Do you know what I mean? Okay, so this is 900. This is going to be 60 short of 900, 840. So to find the period, I'll go 840 minus 360. Does that make sense? Okay, so that gives me what? 780, 580? Am I making something up? 480. That sounds much more appropriate. Okay. So now, if our period, anyone want to ask a question about that? Yeah.
Why did you go from 360 to 840?
I could have, for no reason besides the fact that it's the maximums, I could have also gone from the minimums. I could have gone from here to here. Do not, I mean, you could have also gone from the central axis to the central axis. But do you know what a possible mistake would be? If you were like, oh, from the central axis to the central axis, right? Well, that's only half of the cycle. So I would go from peak to peak or trough to trough. Okay, now let's put that into our equation. And is this 3 over 4? I think so. Okay, so we have a k value of 3 over 4. Okay, let's add that to the list.
So we always write in fractions, right?
Yeah, definitely.
But why?
Because it's more proper. Yeah.
When you find like the period like that, is that like the stretch factor or is that
Yeah. So this is not the stretch factor. Okay, but it's the k, right? So the stretch factor would be 1 over k. So folks, yeah, what is the stretch factor? Give me the number. 4 over 3. Does that make sense? If it's 4 over 3, that would imply that we're stretching the function. Are we stretching it? Yes. How do you know we're stretching it? What's the period? Come on, wake up, you can do it. 480. It's greater than 360. So we took that function and we stretched it just a bit. Okay? All right, now step 4. All right, put that game away, dudes. This is the big one. Step 4. Choose your own adventure. You get to decide whether you're going to use sine or cosine. Okay? So for sine, pick a point at the middle where the function is increasing. So if I were doing sine, this is the start of the sine function. The sine function starts at the central axis and increases. So I couldn't use this one because this is the central axis and decreasing, not the start of a sine function. I could have also used this point, but that's kind of obnoxious because that's a ginormous phase shift, right? Let's make the smallest phase shift possible. Now, if I were to use a cosine curve, where does a cosine curve start? At the peak, right? So this is where I would start my cosine curve. So just because we are keen, we're going to do both, okay? So let's start off with the sine function. Y equals, what's my A? My A is 7. Sine, because we have a K value, we need double brackets. Okay, now I need to think about the phase shift. So for sine, my function has shifted to the right. How many? 180 plus 60. This here is 240 degrees. So because it's moved to the right, I go x minus 240 degrees. And then my vertical axis is plus 4. So this is my phase shift.
Why did you choose minus 240?
Because I have to find out where does sine start. Sine starts here. So it's 240 to the right. So you go minus 240.
Okay, but why does it start there?
Sine starts at the central axis when it's increasing.
Okay.
Now, what is the phase shift of cosine? Oh, it's kind of nice. The phase shift of cosine is 360 to the right. All right, so if we're writing the cos curve, it's again y equals 7. Like nothing, the only thing that changes is that now you're going to write cos, and we're going to write minus 360 degrees plus 4. Does that make sense? Ish? Yeah. Yeah. Oh, yeah, good. Yes, you are. You have to include degrees in the equation. All right, folks. Let's get going. We got 40 minutes before lunch. Okay. And I just had a thought. I think I said it already that on Monday when we have the quiz, again, I will give you like 20 minutes to ask me questions, warm up, right? Because it is right after the weekend. Okay, yeah. All right, let me stop this video.